Our last two problems are difference quotient. So you're given the expression, and then we're going to plug f of x into it. And really, the thing that you need to be careful, two places. One, you have to be careful when you're plugging in, especially with the f of x plus h. And then the second thing is to be very careful when you're with your negatives, especially when you are simplifying your expression. Okay, so here we go. Here's our f of x. So when we're plugging into f of x plus h, what happens is with every one of our x's, just for that piece, they're going to become x plus h. So for f of x plus h, just that piece, I have x plus h squared that replaces that x for the squared term. And then I have minus x plus h that replaces that negative x term, and then plus 1. So that's the f of x plus h portion of this problem. And now we're going to do the rest. Now I have minus in between. This is a big fraction. Minus f of x. So f of x is just this guy as it sits. That whole thing. Minus, I'm going to put it in parentheses because it's the opposite of the whole thing. X squared minus x plus 1. And then it's all over h. This is the difference quotient. And this is algebra that you will get very used to doing in calculus. Okay, so my next step is to expand my squared and distribute my negatives. So carefully with our algebra, x plus h squared. Remember, that is x plus h times x plus h. What I'd like you to do is pause the video and go ahead and expand that, combine your like terms so you have that all ready to go. All right, hopefully you have that ready to go. X plus h squared is the same as x squared plus 2xh plus h squared. That's just that first binomial. Now we need to multiply through our negative. Negative x minus h. Don't forget our plus 1. And multiply the negative through our f of x as well. Negative x squared plus x minus 1. Flip all those signs. And this whole mess is still over h. And our goal with this process is to get rid of h. Because if you can do that, then eventually you can take the limit as h approaches 0. Now we're going to combine our like terms. So I see a positive x squared and a negative x squared. Those cancel. A positive 1 and a negative 1. Those cancel. And then I have 2xh and h squared. Oh, negative x and a positive x. Those cancel. And I have this minus h. So everything canceled except for 2xh plus h squared minus h. And that's all over h. And as good little algebra students, we know that before we cancel, we should probably factor. My numerator has all h's in common. So I can factor out that h so that I can cancel legally. Beautiful. 2x plus h minus 1. You don't have to cancel all the h's. The goal is to get the h out of the denominator. And if you were unable to get the h out of the denominator, then you know something went wrong. All right, I'll do the next one on the next video so this video doesn't get too unwieldy.